Okay, let's dive into a really cool puzzle. Think about this for a second. How fast are you moving right now? No, I mean right now, just sitting there. It's wild to think about, right? We're all on this giant spaceship called Earth, hurtling through the cosmos, and that leads to a super interesting question. When are we actually moving the fastest? Let's figure this thing out.
So where does this whole question even come from? Well, our story kicks off in a pretty weird place, with an old ad from a Parisian newspaper. Get this, it was promising this amazing travel experience for next to nothing, just 25 centimes. And, a few curious people were intrigued enough to actually send in their money.
So what did they get for their money? A letter. A letter that basically said, hey, you're already traveling thousands of kilometers every single day just by being on Earth. As you can imagine, the guy who placed the ad got hauled into court for fraud. But his defense? It was absolutely brilliant. He just stood up and, channeling the great Galileo, said, "It turns." And you know what? He wasn't wrong.
Okay, so that's a funny story, but this little con actually points to a real, fascinating scientific question. We're not talking about how fast the Earth itself is moving. No, we're talking about our speed, your personal speed, as you get carried along for the ride. So let's get right to it. Here's the big question. As we're all on this journey around the sun, when do we move faster? During the day or at night? What do you think? Just take a second. What's your first guess? All right, to figure this out, we have to get one thing straight. The speed of the Earth itself as it goes around the sun is pretty much constant, but our speed, that's a different story. It actually changes. See, our personal speed is a mix of two separate movements, and that's the key to the whole puzzle.
Two motions, one journey. Yep, that's exactly it. To get to the answer, we got to break down our movement into its two main parts. You've got the Earth's big trip around the sun, and then you've got its own daily spin. Okay, first up is what scientists call orbital translation. This is the big one, folks. Our entire planet is just screaming through space at a staggering 30 kilometers per second. I mean, just try to wrap your head around that. Every single second. It's absolutely mind-blowing.
All right, the second piece of the puzzle is the Earth's spin on its axis, its axial rotation. Now, if you're at the equator, this is moving you at about half a kilometer per second. Yeah, okay, it's way slower than that orbital speed, but hey, it's still moving, and it's definitely a big deal for our calculation.
So we've got these two speeds, right? The orbit and the spin. But here's the secret sauce, the real aha moment. It's not just about how fast they are, it's about the direction they're going. Because depending on the time of day, these two speeds are either teaming up or fighting against each other.
Okay, let's break this down. It's actually pretty simple when you see it. At noon, when the sun is right overhead, you're on the side of the Earth that's rotating against the direction of the orbit. They're working against each other. So you take that big orbital speed, 30 kilometers per second, and you subtract the rotational speed, half a kilometer per second. Your total speed, 29.5. But now, fast forward to midnight. You're on the other side of the planet. Now the Earth's spin is moving you in the same direction as the orbit. They're working together, so you add them up. 30 plus 0.5 gives you 30.5 kilometers per second. See? Faster at night.
And there you have it. The answer is crystal clear. We are moving faster at midnight. Now, you might be thinking, well, I don't feel any faster. And you're right, you don't. But let's just put this speed difference into perspective to see how significant it really is.
This chart just makes it super obvious, right? Look at that. The bar for your midnight speed is clearly, measurably higher than your speed at noon. Okay, as a percentage, it's not a huge leap, but when you look at the raw numbers, yeah, it's a pretty big deal.
So what's the difference? 1 kilometer per second. Let that sink in. If you're at the equator, you are traveling a full kilometer farther through space every single second at midnight compared to at noon. That is just wild to think about.
Now there is a little catch here. Your location totally matters. This effect is maxed out at the equator, where the planet is spinning the fastest. But as you move north or south towards the poles, that rotational speed gets smaller. So, for example, if you were in St. Petersburg, which is way up there on the 60th parallel, the difference is only half as much. Still, half a kilometer per second, that's nothing to sneeze at. So, the next time you're up late, maybe looking up at the night sky, just remember, you're not just enjoying the view, you're actually getting a little speed boost on your trip through the cosmos. And it kind of makes you wonder, right? If our speed is changing by a whole kilometer per second just because of the Earth's spin, What other huge, unseen cosmic motions are we a part of right now? Our whole solar system is moving, our galaxy is moving. It's a pretty amazing journey we're all on.